properties of matter.
Study of the properties of matter?
Branch of science that studies chemical substances and elements.
And you said chemicals.
Substances and elements.
Looks at the reaction of two or more different chemicals.
So we're going to explore. Oh, Mikey, what do you have?
I had the study of the periodical table of elements.
You guys are absolutely correct. Those are all of the things, or all things that are included under the umbrella of chemistry. Now, it seems like a very peculiar place to start biology. So we did, what is biology? What's it mean to be alive? We looked at scientific method, and now we're going into chemistry, which you take next year. You spend a whole year taking it. The reason that we go in the order that we go is because of what chemistry is. Everything you just told me, absolutely true. Chemistry is the study of matter and the changes that matter undergoes. So it is an entire branch of science that studies matter and the changes matter undergoes. Now, in order to understand that definition, we have to know what matter is.
Anything that takes up space or has mass.
Anything that takes up space and has mass. So that pretty much means like everything living, right? In fact, it doesn't pretty much mean everything living. It means everything living. And it means everything non-living. So your desks, your tables, the rocks in the turtle's tank, all of those things. It does not include what?
Energy.
Does not include energy, which then includes the umbrella of what other things? Light.
Fire.
Fire, so heat and light, right?
Sound.
Sound. So radio waves, anything with that like weird physicsy dual nature thing that we talk about, like that whole wave sound thing. Thoughts, ideas, those things are not matter. So chemistry won't study them. But everything that we do in biology is dependent upon chemistry. You are just one giant chemical factory. That's what your body does. That's how it operates every day. It's all just different kinds of chemicals. So we start in biology with that because everything living is made of matter. What did you come up with? Atom.
It's the smallest unit of matter that cannot be broken down and is made up of protons, neutrons, and electrons.
I just did the lazy chemist thing for those of you who are curious. From now on, you'll never see me write the words protons, neutrons, and electrons because that takes like way large amounts of effort. So instead, when I write the word proton, I just do a lowercase p with a superscript of a plus. When I write the word neutron, it's a lowercase n with a superscript of a 0. And when I write electron, it's a lowercase e with a superscript of a negative.
They're the building blocks of all things.
I had pretty much what they had, but I those electrons in empty space?
Lots of empty space, right? Lots of empty space.
It can't be created or destroyed.
They're not going to be created or destroyed. You'll notice I did elaborate upon one of the initial definitions that said they can't be broken down. We can't break them down and retain their identity. So if you take away a piece of it or a part of it, like an electron, its identity changes. That we can't actively go like pluck an electron. I can't just like go in there and pull one away. But it gladly will take one from somebody else or give one to another depending who it is. So we have to be careful with that one. This whole proton, neutron, electron thing, something tells me, now this is curious for me. Are you guys of the Jimmy Neutron generation?
Yeah.
Okay. This is where I have terrible news for you. Jimmy Neutron lied to you.
What?
Yep, I know. Because you want to draw me an atom that looks like this. Right? Saw it on Jimmy Neutron. It must be true. That is actually a fairly old model of the atom. It is not the accepted model of the atom. We don't have a pretty graphic for the producers of Jimmy Neutron to replace this with, because what the atom actually looks like is a whole lot of empty space. I don't know how you put a whole lot of empty space in a picture. So what we rely on now when we depict or draw the atom, it does have two regions. So that much is true. There is a center of the atom, which they depict as like small little round things. And there is an outer region of the atom that they depict as these like concentric circles, right, going all different directions. Atoms are going to have those two parts, a central nucleus that's composed of protons and neutrons. And it does have that outer region that we call the electron cloud. I don't have to tell you what the electron cloud is composed of, right? Truthfully, it's not actually all that many electrons. The electron cloud is a whole lot of empty space with electrons that are constantly moving. Now here's why the Jimmy Neutron model is a bad model. Jimmy Neutron model tells you that it moves in this like perfect circular orbit, right? It just keeps orbiting around the nucleus. Electrons are more like, what is that movie with Red and the wolf? The wolf is a reporter.
Oh,
Hoodwinked. You guys seen Hoodwinked? Those of you who have seen Hoodwinked, you know the little squirrel when you give him caffeine? That's an electron. That's what they do. Completely unpredictable. You never know where it is. For those of you who are like, I've never seen it. Have you seen a fan moving? At any given point, can you tell me where the fan blade is if the fan is on high? As soon as you tell me where it is, it's moved, right? You can give me a region of high probability of finding the fan blade. How would you know where the high probability of finding the fan blade is?
The area where the fan is.
Area where the fan is, and it looks like something. What's it look like?
Looks like this kind of blob that you can't really make anything out.
It's a blurry blob, right? And you know at any given point in time, if you take your fingers and you stick them in there, you will encounter the fan blade. Agreed? It's a terrible idea. Don't do it. Don't do it. Someone's going to go home and do it. But you know that you can give me a region that's shaded in. That's a more accurate depiction of an atom. It's where we shade the electron cloud in, and we simply say we never know where an electron is because they're constantly moving very, very quickly. But we can say there's a high probability of encountering an electron in that electron cloud. That's why I feel like you've been lied to, because this tells me I can just simply trace the orbit and find one. Well, that's not true. I can't do that. No, it's not everything you know is a lie. Everything you know is generally a gross oversimplification. We all do that just so we can understand it. Our brains are only so capable. If I were to give you some kind of scale for what an atom looks like, if I put a big shooter marble, you know the big ones, a big shooter marble, at the 50-yard line of the football field, the electron cloud would be on the track itself, and it would be about the size of the tip of your pencil lead. So the nucleus is much bigger. You have this teeny tiny little thing on the outside that would constitute an electron, and everything in between is empty space. So there's two parts to our atoms, the nucleus, the electron clouds. Nucleus is made of protons and neutrons. Hey, if you're made of protons and neutrons, what charge do you have?
Positive.
You have positive charge, right? Because you're made of a positive thing and a neutral thing. And our electron cloud, of course, with the superscript of a negative, what charge does it have? It's negative. What did you tell me an element was?
A substance made up of a fixed amount of protons and electrons. There are 118 known elements in the universe.
Fixed protons and electrons.
It's classified through the periodic table.
118 elements. We put them on the periodic table. Another chemist thing, we're too lazy to write the word periodic table over and over, so we just write P table and we assume that we're all talking about the same thing. You're gonna find scientists horrendously lazy. We abbreviate everything. Energy is capital E, periodic table's P table. Elements, we never write their names, we write their symbols. How do you write a symbol for an element?
The first letter is a capital, second letter is lowercase.
All right, this is where we're gonna have to go back to grade school and remember, way back in the day, you learned how to write with that dashed line down the middle of the line. The two big lines were blue and the dashed line was pink. And pink was as high as a lowercase letter went, and blue was as big as the uppercase went. We follow those rules in chemistry. So if I were to write a two-letter symbol like, say, thorium, because you know that's the first two-letter symbol everyone thinks of, capital T, lowercase h. Ladies, this is usually a problem you have more than guys. I don't want to be that person who says this, but ladies tend to get a little bit more creative when they write, and they write things like this. Yeah, those of you who do it, you know you do it. You're like, yeah, that's me. This is an uppercase letter regardless of the size you make it. You can make it as teeny tiny as you want, and it's still an uppercase H. So please keep in mind, as we abbreviate our elements, we must always use the accepted uppercase, lowercase. Just because you've made your A as big as you've made a capital letter, that's still a lowercase a, right? We fall victim to this one frequently in sodium. That's not sodium. Nah, it's not. You killed me. I'm here all day, kids. At least like 3 of you left. Just beware of that. So, any element gets its identity from the number of protons it has. We assign that identity by simply assigning it a number. So, and that number we assign it is the number of protons it has. So I often give this kind of comparison. We don't ever identify an element, especially by its name. We do it by its number. That's just like you guys. The United States government does not identify you by your name. It identifies you by your social security number. So if you were born in the United States, when your parents are in the hospital, this is what happens. They're trying to celebrate your birth. Yay, joyous, fabulous, fantastic, look at this new life, etc. And all of these employees of the U.S. government come knocking at the door. Their job at that hospital is to get your name and make sure your parents have the paperwork for applying for your social security number. As far as the US is concerned, your identity is based on your social security number. Why? Because your name's not especially always unique. Your name is, you know, like in college, I lived with Erin Smith. Her last name was Smith. Just at the University of Michigan, do you know how many Erin Smiths there were? 6. 6 between freshmen to seniors. 6 people in one city with the exact name. 3 of them were Erin A. Smiths. So that wasn't an especially useful way to identify someone. So think of the number of protons like the social security number. We call the number of protons the atomic number. And that's how we've organized the periodic table. It's by increasing atomic numbers, starting at number 1 and working our way to the most. So it goes from 1 all the way to the most. And we just put them in order. Yep.
So is it, do we actually number like the protons in the nucleus, or do we just like?
Just count them. We don't technically actually count them. We do it by mass, but does that mean we can't make it hold still long enough? Count it. It's really tiny.
So since there's the same protons and electrons, could you just count the electrons?
No, because electrons we can lose. That's the problem. When the electrons are hanging out on the outside, we can lose them. So we always count protons. I want to introduce you to some of the elements that you'll need to know, and you will be having a quiz on these elements on Monday. So the reason I told you to have an app open in which you can make flashcards is I'm assuming you want these in a place you can study, right? And some of you are like, meh, I'm like a champion at the elements. Well, if you're a champion at the elements, good job. Don't be overconfident. You'll spell some of them wrong, and spelling counts. Now remember yesterday I also gave you the speech about how we make our letters and we make the abbreviations? Just like you were taught in the first grade by Mrs. Adamian. Okay, I was taught in the first grade by Mrs. Adamian. I don't know who taught you. But, you know, they did a good job. They showed you how to do it.